All right, so 2019, question 2. It's a popular question because it's a good sort of mathematical tool of some data. From the enthalpy of combustion data given below for the alkanes, methane through octane, test the extent to which this relation holds. So in other words, what they're saying is mathematically, in the world of this could be considered Y, and I guess molar mass would be X. What is the graphical relationship between these two? And is it related through this exponential style of doing it? So if you were to graph this, you get this function. How well does this data fit on that line? In other words. So the classic trick with something like this is right away, you can see delta H equals Km to the n. Take the log of both sides. And let me see if I can zoom in a bit here. If you take the log, the log of both sides. So if I take the log of delta H and I take the log of Kmn, right? So the rules of logarithms say that anytime, so this is me thinking, the log of A times B, you are allowed to split it up like that. I'm also thinking ahead in case we need it. Log of A divided by B, just in case we need it. This is you populating your mind here with logarithm rules. Or the log of, let's just say, A to some, exponent C. You are allowed to take that down in front, C times the log of just A. So you can see how these can apply to this. So why don't we split these two up first? So you could get log of K plus the log M to the N. And we could bring that N down front. N log of M. And you're looking at this and you're thinking, wow, that looks like Y. That looks like B. That looks like slope. And that looks like X. So this is a straight line relationship. So what this says to me is if you were to graph the log of delta H versus the log of molar mass, you'll get a straight line. Here's the important part though. When you're, remember that, for example, that you've got methane. Methane is listed as negative 890 kilojoules per mole. The sign has no mathematical meaning per se in this graphical relationship. So in other words, this just refers to the direction of the heat flow. Is it in the system or out? So when you're going to do, if you were doing this on paper by hand, log of this, so, right, and this would be your delta H's, and then you're going to have your M's. If this is your exam, right, you're setting up some columns for yourself and saying, okay, I'm going to drop the sign. So drop the sign. The next one would be 1560. Well, now you just take the log of this and get your numbers. Graph just the positive numbers. So if you do that, you should get some sort of line that looks like this, right? And Excel, if you did that, or your calculator will spit out the value of B, so you get K. It'll spit out the value of M, and yes, it'll spit out these two for you. And then the R value, or R squared value of how well it fits the straight line, indicates how well this mathematical relationship is followed. So this is how you do the question, folks. So to answer the question, I guess what you're saying is you show me the y equals mx plus b graph here of this relationship in the r squared. You can make a comment about that, and then you can use that equation. If you put in decane, you know it's molar mass, you could calculate delta H using this relation. So that would take care of question